Welcome back, children. Now I am going to begin with another chemical property, that is reactions with acids. Reactions of metals as well as non-metals with acids. Before that, I'll tell you we studied about HCl, H2SO4, hydrochloric acid and sulfuric acid. We are going to do the reactions with only these two acids. Now next thing is dilute acids, concentrated acids. I am not going to do any reaction with concentrated acid. Rather, we are going to perform all the reactions with dilute acids. Now, what do you mean by dilute acids? When acids have less strength of acid, much more water has been added to it, it becomes dilute acids. And in case of concentrated, less water is there, it is rather the strength of acid is more in this case. So this is very strong acid as compared to the dilute acids. We are not going to do any reactions with HNO3 as it is a strong oxidizing agent. So you don't know about this oxidation and reduction, we have not studied, so I am not going to touch this. So we are going to do the reactions of metals and non-metals with dilute acids, that is hydrochloric acids and sulfuric acid. Now, metals react with dilute acids such as hydrochloric acids and sulfuric acids to form their respective salts with the evolution of hydrogen gas. The metal displaces hydrogen atoms of the acid to form salt. Now, how do you come to know that the hydrogen gas is being evolved? If you take metal, suppose I take magnesium metal, but that ribbon, the small piece of magnesium ribbon, and add dilute HCl into it. After some time you will find that it reacts, and if I keep my thumb over here, I'll find that I'm feeling some pressure, that is which is being put on my thumb. Now if I bring a matchstick, burning matchstick, we can hear the pop sound. Now, what is this pop sound? Like a balloon ruptures, that kind of sound you can hear. So this proves that hydrogen gas is coming out. Hydrogen gas is evolving. If you bring a burning matchstick near this gas, it burns with pop sound. This proves that hydrogen gas is being evolved. Now I'll show you some reactions. First, with sodium and hydrochloric acid, it produces sodium chloride. We call it sodium chloride. Sodium chloride is common salt, we use the salt at our home. This is sodium chloride and hydrogen gas. Magnesium with hydrochloric acid, it forms magnesium chloride and hydrogen gas. Same way, if I react magnesium with sulfuric acid, I will get the salt magnesium sulfate plus gas is hydrogen. This is magnesium sulfate. Same way, zinc. This is also reactive metal. Hydrochloric acid. I am not balancing it here. Then it is zinc chloride plus hydrogen gas. Same way, we call it zinc chloride. Calcium is also a metal with hydrochloric acid. This gives calcium chloride plus, this is a violent reaction, children. Here you can see the violent reaction, it reacts vigorously, and aluminium with hydrochloric acid, AlCl3, this is aluminium chloride, hydrogen gas. Then we have iron with hydrochloric acid, this will give you ferrous chloride. It is ferrous chloride, so I am writing FeCl2. If it had been ferric chloride, I would have written FeCl3. This is ferrous chloride plus hydrogen gas. And copper does not react with dilute HCl or dilute sulfuric acid also, it does not react with. No reaction of copper with dilute acids because it is very less reactive. Now I'll repeat it. Sodium with hydrochloric acid, sodium chloride, hydrogen gas. Magnesium, hydrochloric acid, magnesium chloride, hydrogen gas. Again magnesium with sulfuric acid, magnesium sulfate and hydrogen gas. Zinc with hydrochloric acid, zinc chloride, hydrogen gas. Calcium with hydrochloric acid, as I said, it is violent, it shows violent reaction. Calcium chloride plus hydrogen gas. Aluminium with hydrochloric acid, aluminium chloride and hydrogen gas. Iron with hydrochloric acid, iron ferrous chloride or iron chloride also you can say, plus hydrogen gas. Copper does not show any reaction with dilute HCl or dilute sulfuric acid. It does not show any reaction with dilute acids. Metals like sodium, potassium and calcium, they react with dilute acids vigorously. Even potassium. Potassium chloride plus hydrogen gas. This also reacts vigorously and salt is formed, hydrogen gas is produced. As far as non-metals are concerned, they don't show any reaction with acids. So non-metals again, if we see the non-metals are not showing any reaction. They do not react with acids. Suppose we compare the acids, the acidic reactions with three metals. Suppose I take iron metal, zinc and copper. I'll take beakers, 250 ml, 3 beakers. And dilute hydrochloric acid and these three metals: zinc, iron, copper. This is zinc, this is iron, this is copper. Take about 100 ml of dilute hydrochloric acids in each of the three 250 ml beakers. Number them as 1, 2, 3. 100 ml dilute HCl. Now put the zinc in beaker number 1, iron in beaker number 2, and copper in beaker number 3. After some time, you will observe that zinc liberates. I said zinc forms ZnCl2 plus H2S. This produces hydrogen gas very briskly. Very briskly means vigorously. And iron liberates hydrogen gas slowly. This does it slowly. And in case of copper, you will find no reaction. It is the least reactive metal. So now if you want to, we are going to study about reactivity series of metals next day. That day I'll give you the list of metals. There you will find the list the sequence of metals. This will be above this and this will be above this. Means if you find the sequence will be in this order. This will show the reactivity of these metals. The most reactive is considered to be zinc, then next is iron, and then next will be copper. This is the least reactive. Now there is a term called aqua regia. Why I am discussing it? This is a question given in the back exercise. What is aqua regia? Aqua regia. Aqua regia is freshly prepared mixture of concentrated nitric acids and concentrated hydrochloric acids in the ratio of 1:3. This mixture is highly corrosive and fuming liquid. It is highly corrosive and fuming liquid. The other name of aqua regia is royal water. Now what happens if you go to a jeweler and give some jewelry, gold jewelry to it or silver jewelry also, to clean it, gold jewelry, he will clean it and you will find the weight of jewelry getting little reduced, because when he dips this jewelry into this solution, this mixture, it dissolves this top layer of that jewelry. So this aqua regia can dissolve all metals, including the noble metals. Noble metals, we call those metals which are very less reactive. So least reactive metals are known as noble metals, and like gold, platinum, we call them noble metals. Gold, platinum. But if you want to clean these metals individually or separately, either in concentrated HNO3 or in concentrated HCl, it won't do work. It will work only when these two are mixed. So it works only in the mixture which is known as aqua regia. So though its constituent acids alone cannot dissolve them, it can be done only in the aqua regia. So what is aqua regia? Aqua regia is a mixture of nitric acid and hydrochloric acid in the ratio of 1:3 by volume respectively, and it helps in cleaning or dissolving these metals. Correct? Now we will be studying about reactivity with bases. How bases react with, how metals and non-metals react with these bases. Suppose you know the name of some of the bases? I can take example of sodium hydroxide. This is very common. We have used it in class 6th also. So sodium hydroxide is a good base to be used here. So let us see how metal reacts with sodium hydroxide. We can do one activity with this. Prepare a fresh solution of sodium hydroxide. How will you prepare it? You will take some 3 to 4 pellets of sodium. This is available in the lab. We will use a plastic tong to take out these 3-4 pellets and add water to it. It will become sodium hydroxide, and this you take in a test tube, add aluminium. In this, if you add aluminium to sodium hydroxide, you will hear a pop sound if you bring a burning matchstick near this gas. That means which gas is being produced? Hydrogen gas. So we will find that metals react with sodium hydroxide to produce hydrogen gas. I can show you the reaction. Aluminium and this will form sodium aluminate, NaAlO2 plus of course hydrogen gas. This is known as sodium aluminate. Same way you can see one more reaction, zinc. Zinc plus sodium hydroxide. Sodium hydroxide is very strong base. It is very strong base. So if you react zinc with sodium hydroxide, it will form sodium zincate, Na2ZNO2 plus hydrogen gas. This is known as, this was sodium aluminate, this is sodium zincate. So I repeat this. Reactivity of metals and non-metals with bases. Oh, sorry, I think you have not seen it. Anyway, I will repeat it. Reactivity of metals and non-metals with bases. Here we are going to study about this base, sodium hydroxide, which is a very strong base. How you will prepare it? You will add 3-4 pellets of sodium and add water in a test tube. It will form sodium hydroxide. In this you add aluminium, put little small piece of foil of aluminium. The reaction will be like this: sodium aluminate NaLO2 plus hydrogen gas will be liberated again, and same with zinc metal. In place of aluminium, if you put in zinc metals are also, granules are available in the lab. This is added to it, and sodium zincate Na2ZNO2 is, this sodium zincate is formed and hydrogen gas is produced. Now, what about non-metals? I'll again write this. I think it was not clear over there. I'll write it here again. Aluminium plus sodium hydroxide. First of all, we formed a solution. Now this will form NaAlO2 plus hydrogen gas, and this is known as sodium aluminate. And in other case, zinc plus base, this is a metal, this is a base, metal base, this will form Na2ZNO2 plus hydrogen gas, and this is known as sodium zincate. Hydrogen gas is produced here. This is about metals. Now what about non-metals? Non-metals also reacts with base, but these reactions are complex one, so we are not doing it in this class. The reactions of non-metals with bases are complex ones, so we are not going to do it in this class. Anyway, then you have a table number 4.6. Table 4.6 in your textbook. You complete this table. Tomorrow I'll be discussing it with you. I hope everybody has understood so far whatever we have studied. So I'm going to check your knowledge tomorrow. Till then, enjoy the day, keep yourself healthy, happy, and bye.